Our next presenter comes to us all the way from the OpenSIPS core team again. We have Razvan Crainea. He will be presenting to us DTMF Handling in OpenSIPS 3.1. He's got a presentation and a demo for us. So this is going to be really fun. Razvan, take it away.
So first of all, I would like to thank Alex for the nice introduction that he's always doing for all of us. Thank you, Alex. And I would also like to thank Max for handling this awesome conference. And not only that, you'll see throughout my presentation that he deserves a lot of credit for the things he's done up until now. But yeah, we'll all see. Okay, so today I will be talking about DTMF handling and how you can handle DTMFs in OpenSIPS 3.1. I will talk about the two projects that we require or that work along with OpenSIPS in order to provide these DTMFs. I will show you a few use cases that I've used and a demo that is going to be hopefully quite interesting for you. So let's get started. First of all, what are DTMFs? DTMF is an acronym from dual tone multi-frequency signaling. So although the name is a bit cryptical, you can see the DTMF keys as the keys that you're asked to press when robots are asking you to do stuff during a call. This mostly happens in IVRs, the interactive voice responses. So it basically it appears basically when you call to a number, a robot's answered and asks you to do stuff like if you want to talk to speak English, press 1. If you want to speak Spanish, press 2. And the DTMF key is basically the key that you press. It has a limited chart set, so the most commonly used are numbers, star, hash, and some dial pads have the A to D keys. There's also two ways of delivering DTMFs in VoIP, out-of-band and in-band RTP. We will be talking about this a bit further. Out-of-band DTMF keys is out-of-band means out of the media stream. So if it's out of the media stream, they will basically go through SIP. So whenever you press a key on your dial pad, a SIP message will be sent to OpenSIPS or to the proxy or directly to the other user agent. And a 200 OK will probably come in saying that the key was received. There are two ways of doing this SIP-wise. One is the in-dialog request. So basically trigger an info message inside the dialog. That's RFC 2976. Or you can also use a presence mechanism where a phone registers for a specific event saying, hey, when Alice presses this key, notify me. This is RFC 2848, which is not that much used. In practice, I've never seen it being used, but it's there for legacy purposes. However, the in-dialog request is quite used RFC, and you've probably met it up before. All these out-of-band DTMF keys are basically encoded in a text payload and are part of the info or notify payload. So having them proxy through OpenSIPS gives you the entire possibility to read the body, check out what was the press key, and so forth and so on. So it gives you the flexibility to do the loads of actions on in the OpenSIPS side. For the in-band DTMFs, things are not that simple. Okay. Seems like my animation is a bit screwed here. Anyways, for in-band DTMFs, basically the keys are sent in the media stream. So if you get Alice and Bob, although the dialog was established through OpenSIPS, so through a proxy, if you have Alice and Bob talking to each other through the RTP channel here, the DTMF keys will also be sent through this channel. This means that we, from OpenSIPS side, we don't have access to these keys. So in order to intercept them, we require a media relay. We require somebody to step in between the RTP flow and intercept the RTP traffic, decode it, and send it and inform OpenSIPS about the DTMFs that are flowing through this RTP flow. These media relays basically there are two projects that support DTMF detection. One of them is RTProxy and the other one is Rtp Engine. And OpenSIPS 3.1 has support for intercepting DTMFs for both media relays. In terms of encoding type, so the way the payload goes through the media relay, so the RTP, sorry, there are two types of encoding. One is audio tones, which is basically the key itself is encoded in a special sound that needs to be decoded. So you really need to take the RTP packet, decode it in order to find out the DTMF. And later on, the named telephony events, the NTAs, RFC appeared in RFC 2833, and later that was later obsolete, but by 4733, which describes how an actual RTP packet should be constructed with a different payload type in order to easier detect these DTMF codes. Okay, let's see how each of these two engines use how they detect DTMFs and how they are informing OpenSIPS about them. The first one that we are talking about is the Rtp Engine, which is developed by the SIPwise company. It's basically started as an RTP media relay, which later got support for RTP to SRTP bridging. It also has support for audio transcoding, playing back medias, doing call recording, and later on intercept DTMFs. Rtp Engine can also log the DTMFs in at the syslog, but it can also send them to a specific destination where somebody can intercept them. Rtp engines had up until now had a quite interesting notification mechanism. So, for example, in order to tear down a call due to lack of RTP, one had to configure an XML RPC back-to-back callback that were triggered by the Rtp engine. So if you would have set here RTP XML RPC request to OpenSIPS saying tear down this call, it would have gone through MI. So you'll have to load the MI XML RPC and G module in order to receive the notifications. Although this was a bit let's not say complicated. It required some extra modules such as the MI XML RPCNG module. However, when they developed the DTMF keys notifications, so the notifications that were sent when the DTMF key was received, that was a completely different approach. So instead of having an XML RPC, which is basically a TCP request that contains an HTTP message with an XML payload, so it's quite it's not that straightforward. They would have developed a very lightweight method of delivering these DTMF keys simply by sending a datagram packet over UDP. So this is a bit this is way lightweight than using an XML RPC. However, the problem was that we didn't have any ways of intercepting these DTMF keys in OpenSIPS. So we had to develop a new interface that was able to intercept these DTMF keys and deliver them to the script. So the datagram packet is basically a simple JSON sent over UDP. So it wasn't that hard to decode the packet. So it wasn't such an, let's say, such a complicated job of decoding it. However, there was I will have to note the lack of documentation for this. So in order to develop all this feature, I had to do a lot of reverse engineering in Rtp Engine. It's not such a big problem because I like to read code, but I would love to have something documented so that proves me that things will not change in the future. But anyways, it works, so we will have to work with it as it is. In terms of notifications, in terms of configurations, both servers need to be configured. For example, in OpenSIPS, you'll have to set up a notification socket, which is basically the UDP listener that the notifications will be sent to. You will have to define an event route for the Rtp Engine notification event. So basically, all these DTMFs events will be sent through the event interface that we have in OpenSIPS that can be intercepted either in a route in OpenSIPS, in an event route, or can be passed further through the event interface. So you can have your own, for example, a RabbitMQ listener that would receive the DTMF key, and you can process it in your own application. So there's no limitation of running it inside the OpenSIPS script, but you can do using the event route. For the Rtp Engine site configuration, you'll have to define, in the configuration file of Rtp Engine, you'll have to define the DTMF log dest parameter and point it to the notification socket you've defined in OpenSIPS. This brings not so nice limitation due to the fact that notifications will only be sent to a single OpenSIPS instance. So you can't have multiple instances of OpenSIPS running using the same Rtp engine, because the DTMF logs will be sent to can only be sent to one specific instance. Of course, you can have some sort of proxies that can determine where the dialogues are and stuff like that, but it's not that straightforward. Also, a thing that I didn't realize or how to do, as I said, there was nothing documented, but you cannot filter whether you want to receive the DTMFs only for specific calls. So currently, if you configure this parameter in Rtp Engine, you will receive all the DTMFs for all the calls that are proxied through Rtp Engine. Again, I couldn't find any documentation of this. So if this is not true, please help me out and show me how I can do this, because it would be of interest for me. So as soon as a key was pressed on your keypad, on your dial pad, a DTMF event would be triggered by Rtp Engine, sent to OpenSIPS, and OpenSIPS will eventually run an event route for Rtp Engine notification event. Probably I forgot to mention, although it was written on the slide here, the notifications that Rtp Engine's triggers are generic. So currently only DTMFs are supported as far as I know, but other notifications will probably be developed in the future. That's why, as far as I could see, the notification event was basically split in two, where the generic fields are type, which indicate, for example, in our case is DTMF, but also have the call ID that generated the notification, the source tag, the timestamp when the key was generated, but also some DTMF notification specific fields such as source IP. So this indicates who's the source IP that generated the DTMF. This is the event, basically it's the key that was pressed, the duration, how long the key was pressed, and the volume. This is something related to, it's probably inherited from the old audio codes, because I'm not sure how volume could affect or could be, how you could issue a different volume. And that's it. That's all you have to do. But let's go further and see how RTProxy does it. Not sure how many of you use RTProxy, but you've probably already learned that RTProxy was developed by Maxim. You should know him already. So let's give all the credits he deserves. Thank you, Maxim, for providing us RTProxy and lots of other stuff in the VoIP industry.
Thank you.
You're very much welcome. RTProxy was developed in 2003 and also started as an RTP media relay. But throughout the years, he developed other functionalities such as playback media, also forking a media to a different destination. And this is quite interesting because we are doing a lot of applications with this feature. For example, this is what we are using for providing SIP-rec recordings, or also the media exchange module that I will present on Friday relies on this functionality to fork the media to a different destination, to a different SIP instance. So this is another cool feature that RTProxy has. Call recording, again, can be done in RTProxy. You can record one leg, both legs of the call, merge the two media streams together, and so forth. And you can also intercept DTMFs, currently only NTEs, so named telephone events, but probably that's 99% of the industry, right? Probably, I've never, actually I did see some audio codes, but probably no one uses it anymore because of the cost of decoding the RTP and understanding the digits inside.
Yeah, it's also unreliable if you're using some high compression codec. So if your stream is compressed with 729 or something like that, it screws up.
Yeah, that is correct. Basically, they only work with uncompressed codecs such as G711.
Totally agree, guys. And all the big ITSPs and are using uncompressed just to have their minds.
Yeah. Yeah. So okay, getting back to the notifications that RTP proxy does. Well, it is able to tear down a call due to lack of RTP, and this was developed instead of using something like an emite command, such as Rtp Engine does. This was developed in OpenSIPS. It's actually something that I developed about 10 years ago, and was probably within my first OpenSIPS projects. The ability to receive notifications for RTP proxy timeout events. But 10 years later, almost 10 years later, almost in 2020, that's something that I modified when Maxime said November. It was November 2019. It's about 2020. 10 years later, I got engaged with Maxime to develop this DTMF detection keys feature. We basically split the work as it should have been. Max has done like 90% of the job, and I also did 10% of the job. So Max, besides developing in RTP proxy and enhancing the modules interface to be able to do packet inspection in modules, after my initial attempt of detecting RTP packets and notify OpenSIPS, he came in and did it the right job. So again, thank you, Max, for that. Also,
it was long overdue. I wanted to do it.
Thank you anyway. So yeah, we developed this as a new module for RTP proxy that can be found in the 2.1 DTMF branch. So there's a special branch in the RTP proxy official sources that you can download and check it out. And it's also present in the master and hopefully in the new 2.2, which is going to be released soon, as Max already told us.
I already pushed the branch. So.
Oh, that's perfect. So I will have to adjust my slides. Thank you. So the fun part was that it was using the same notification mechanism. So theoretically, I shouldn't have done anything. However, there's always a however. The way that we initially developed timeout notifications in 2010 worked very simple. So when OpenSIPS instructs RTP proxy to create a call, it also gives him a token saying, hey, when this RTP times out, send me this token and I will terminate the token. Well, basically that token is exactly the identifier of the dialog, right? So when we receive the identifier of the dialog, we will have to tear down the call. Now, this wouldn't work that easy because when we got the after developing the DTMF notifications, when we got the token, we really didn't know whether it's a timeout notification or is it a DTMF. Well, we didn't know. So in order to be able to make a difference between these two events, we've modified in OpenSIPS the way that that the token is built. So instead of simply giving the dialog ID, we're saying, hey, I want a notification. The token that we build starts with a D for dialog, starts with D followed by the dialog ID. This is for a DTMF notification. You can also have T followed by the dialog ID, which is a timeout notification, which is a RTP dialog timeout. Sorry, should have been RTP timeout here. And also we have the I, which is basically ignore this notification. This is very useful when you are not interested in RTP timeout, but also DTMF notification. You would probably ask me, why am I giving you this information? It's just for you to know and to be able to easily differentiate when doing a trace or when doing encrypt, for example, between the communication of OpenSIPS and RTProxy. You will easily be able to differentiate between the DTMFs and and RTP timeouts yourself. Also, Max has built this generic interface of passing things from OpenSIPS to RTProxy modules. So instead of giving a long line with different identifiers, which more or less at a certain point will no longer scale because it will no longer be, you will no longer be able to differentiate between whether some parameters are for modules and others are for RTPproxy core. Max already developed a way of specifying parameters to a specific module. And for this specific module, the DTMF module, we are using the AIM3 colon 1 identifier. So this, all the parameters after this identifier will be passed through the DTMF module. Some of the parameters that are needed are, for example, what is the payload type that will be used for RTP? Because you probably have noticed the telephone event, which is 101, but that's not always the same. So from your OpenSIPS script, you should be able to intercept the payload type and specify it to RTPproxy so that RTPproxy knows how to differentiate between plain RTP or other or telephone events.
Yeah, I can a little bit explain about 3:1 thing. Basically, we don't use it too much at this moment, but the way we build those modules in RTPproxy is that you can technically load the same module several times. And each time you load the module, it will instantiate one of several threads for this module. So by having the specifier, it allows us to at least technically later on scale for the modules that I'll actually need to do a lot of processing. We don't do a lot of processing for DTMF because it's pretty much, you know, you parse RTP and there you go. But for something like transcoding or something, we want to have some mechanism where you can partition your traffic between multiple instances of the module, and you can basically scale it as you need. Sorry, Razvan, to interrupt.
Oh no, that was very helpful. To be honest, I didn't know why you used that notation, but I trust you. It was a good idea. Thanks for the explanation. Now, in terms of configuration, in OpenSIPS, you basically need to do the same thing as Rtp Engine. You need to specify a notify socket. This time is a TCP listener where notifications are sent to. You'll also need to specify the D flag in the offer you send to RTPproxy, because since the detection of DTMFs is controlled in OpenSIPS, you probably only want to detect DTMFs keys on specific calls. So you should only mark those calls or use the D flag only for those specific calls. And from now on, so basically this is the only thing that you have to do additional to Rtp Engine. After that, you still have to define an event route where for the eProxy DTMF and add the logic to handle the DTMFs. And identical with Rtp Engine, events can be sent further through using the event interface. So you can have your own application that intercepts those DTMF keys and do whatever you want with them. From the RTPproxy side, you will need to have a notification set. So the -n parameter, unfortunately, I forgot to put it here. and also load the module in the master branch. So starting from the master branch, you will need to load the DTMF module. But that's it. Using this more or less deep.
Just a little bit of correction. The
Yeah.
DSO mechanism is basically, it might work for the simplest cases. I'm not 100% sure if it works for DTMF module, depending on whether or not there are some parameters in the module that you need to set, because it doesn't allow to pass any configuration parameters. So for example, if you take HEP module, for example, it takes HEP server, obviously, HEP protocol, and all those parameters. So instead of using DSO, you will need to put a configuration file.
Okay.
Those parameters in.
This is the way I used it to test, so it was working just fine. But okay, yeah, indeed, you don't really need to configure that much in DTMF, in the DTMF module. I've never used the HEP one, and there was another question that I wanted to ask you, but unfortunately there was not that much time. I will ask it afterwards. But anyway, all you have to do is load the module, specify a configuration file, as Max said, and that's it. Using this approach, you will make sure that you can use RTProxy from multiple instances. So you are no longer bound to a single RTP, to a single OpenSIPS instance. You can use the same RTProxy instance with different OpenSIPs, which is kind of cool. The eDTMF, eRTProxy DTMF event has more or less the same information like Rtp Engine. This is not a generic notification event. So as you can see, the name is not eRTProxy notification. It's just DTMF because you can only receive DTMF events using it. But you'll also get the digit, the duration, and volume. So these are the, you'll also get this in Rtp Engine. There's also one more catch, because you can receive an identifier which indicates you can bound the DTMF to a call ID or to a dialog ID. This is more or less an internal optimization, because, for example, you might have a case where you cannot create a dialogues, or you're not using OpenSIPS with dialog support. So, but you still want to get DTMF keys. So in that case, you don't have a dialog ID, but you do have a call ID. So instead of the module, instead of providing the dialog ID, which it doesn't exist if you're not using the dialog module, it will provide a call ID. And it's very hard to understand whether this ID represents a dialog ID or a call ID. So that's why we added a different switch. And also, finally, there's a stream which indicates the stream index of RTProxy session. Basically, this indicates whether the callee or the caller has sent the DTMF. 0 is for caller and 1 is for callee. This is usual. This is the usual way it works. However, if you have like a more complex SDPs where you have multiple media streams, this will basically translate to 0 and 1 would be the caller, and 2 and 3 would be the callee. That's because you have two different. You'll have two media streams for each participant. Okay, so basically this is how it works. Let's see a couple of use cases that we've thought of or we've used. Well, one thing that you can do, and I've been asked several times how you can do that, is how you can translate inbound DTMFs to out-of-band SIP events. So as I was saying earlier, in-band DTMFs float through RTP, but some of the endpoints do not understand these in-band DTMFs, and they only work with SIP events. So you might using this new approach, using this new DTMF notifications, you'll be able to notify OpenSIPS, and OpenSIPS will be able to send SIP events that correlate with the DTMFs. I will show you in a couple of minutes. You can also have some sort of simple setup where you have a call between A and B, and you can have a requirement if one of the parties don't input a pin within 10 seconds, let's say, then you terminate the call. I will show you in a couple of minutes how you can do that. You can also have a way of transferring a call when a specific key was pressed. So if I'm talking to, let's say, to a hospital, and the hospital says, well, you shouldn't call here, just dial *123, then I can be transferred to that extension. You can have that as well. Or, for example, you can play back a message bound to a specific key. This is the only one that I don't have a demo yet. That's because I detected the limitation in RTProxy code in OpenSIPS, but I will soon fix it. These are the resources for my presentation. So here you can find the RTProxy project, which I noticed Max didn't advertise on his contacts. He should have. This is the Rtp Engine one, so it's basically the GitHub sources. Of course, RTProxy is also open source and available on GitHub, but I just pointed out the project site. Here you have the documentation of the two events that we have been developed in OpenSIPS 3.1, one for RTProxy and one for Rtp Engine. And finally, at the beginning of the year in March, I've written a blog how to use it. So this how to use the new DTMF detection. So this presentation only complements that blog. So you can find out a lot of information in the blog as well. Okay, so let's do the demo now. Let me switch my screen. Stop sharing.
I'm having trouble containing myself. Hurry up.
I'm sharing my entire screen now. Yep, share it. Okay, I have here a console and an lesson grep. You seeing them? Hopefully. Now, this time my test call is quite simple. So I have two different phone calls. I will be using Linphone for the caller and Yell-Link for the callee. Let me start Linphone. We have here Alice. Let's call Bob. Answering. Okay. So now I have a call between Bob and Ollie. Sorry, I hear myself twice because of the call. I need to turn it off. Actually, something else happened. Calling again. Okay, I will now press a few keys. Not sure if you hear them. Okay, the call has terminated. I will explain to you a bit later why. Okay. Okay. Not sure how to get rid of this. If anyone can help me. On the right side, I know there was a. Nope. Okay, let me do another test. Okay, just punch a few keys, and if you take a look to my to the zip trace, okay, let's see. Just a second, I will decrease the font. Can you see my encrypt now?
Yep.
Hopefully. Okay, so what you see here is this is the call establishment, which is up until ACK, everything got established, and then I started punching a few keys on my hard phone, which were basically RTP events sent through RTP proxy, and RTProxy intercepted them, sent them over to OpenSIPS, where OpenSIPS triggered these info messages. So I pressed here 2, then 6, no 5, 8, 4, 6. So as you can see, there's no CP info coming from the callee side. So everything flew through RTP. They were intercepted by RTP proxy, sent to OpenSIPS, and OpenSIPS send these info messages. Let me show you. Okay. Check out the DTMF. I've done some git tags here. This was what I used in order to intercept the notification and trigger the info message. So all I had to do is load the RTP proxy and event route, define the socket that RTP proxy, the socket I used to communicate with RTP proxy, and the notification socket I got the events for, engage RTP proxy for on the invite, answered RTP proxy on the 200 OK, and define the route that handles the event. I essentially used the DLG send sequential message, which sends an info. This is the direction where it sends it, either to the caller or callee, and this is the body, the payload of the info message. However, in order to use this this function, I basically loaded the context of the dialog, and this is what has been done here. I received the dialog ID, which was present in the param ID, loaded the context, and after I sent the request, I unloaded the context. I won't get into that much details about loading and unloading the context because this is what Bogdan is going to present on Friday. But this is an example of what you can do with the load dialog context and unload dialog context messages. Because without them, I wouldn't have been in a dialog context. Therefore, I couldn't have used this function that requires a dialog context. My second demo is regarding requesting a pin within 10 seconds. Let me show you how this works. Okay, so what I've done here is when creating the dialog, I'm using the B parameter. This says send the by when the dialog terminates. I put a dialog timeout here of 10 seconds. And whenever this timeout dialog expires, trigger me this route. Here, I use this route in order to modify the behavior of the dialog. So if within these 10 seconds, I accumulated the 1, 2, 3 pin in the pin variable in the dialog, then I would have extended the dialog timeout to 2 hours. Otherwise, the dialog timeout would remain 10 seconds, and therefore the call would end. That's actually what happened in the first test call I've done. I haven't done anything, so the dialog was terminated within 10 seconds. And here in the RTProxy DTMF route, I added some code to, I added the logic of accumulating the pin value. So all I have to do is first trigger star, and then all the digits after star will accumulate here. After this 10 seconds, if the dialog, the pin is 1, 2, 3, 4, then the call would remain active, right? So let's see how this works. Okay, let me start a new call. One, two, three. So now we'll have to wait for 10 seconds and the call will be terminated. I'm not doing anything. Okay, so the call was hung up. If we take a look at the trace, you will see that OpenSIPS generates the bidirectional after exactly 10 seconds. Let's see. Okay, this is 4750, 4800. So after 10 seconds, the call was terminated. Let's try another call to Bob, where I input the calling star 1, 2, 3, 4. Okay, still going. 8 seconds, 9, 10, 11, and so on. So this was the second demo I wanted to show you.
Hey, Bogdan. Oh, sorry, Bogdan. Razvan.
Yeah.
One thing that I wanted to mention, I actually wanted to bring it earlier in some of the discussion, but keep forgetting, so I'll probably bring it up now while you're doing
Sure.
this. One feature that we definitely need to look at to make this functionality more useful is ability for RTProxy to either scramble or just discard those events. Because in many of those pins bench scenarios, you probably don't want Bob to hear this pin. So it would be really interesting option for the DTMF module if you can instruct RTProxy to
block the
either block or just put a random stuff in there instead of real events.
Actually, there is a question on Slack about this from Artur Sultan Bekov. He's asking if actually that's his second question, if RTProxy can mute the DTMF tones when it's transcoding inbound DTMF to outbound. So basically, yeah, okay, you intercept it from the middle, but just to remove them from from the RTP stream.
So currently there's no such implementation. I know I've discussed this with Maxim, but yeah, we haven't done it yet. So of course that's why I love these discussions, because you always learn stuff from it. So yeah, we'll definitely need to do it, Max. Okay, my third demo and the last one is probably the most simplest one. So here I will make a test call, and when I hit the pound key, I will transfer the caller to SIP to Carol at summit.opensips.org, which is basically my second hard phone here on my desk. So let's see how this looks like. Okay, answering, and I need to press the pound. Okay, now Carol is ringing, answering. Hello, hello. All good. Closing. So what has happened now was I started the call here. The call transfer. So when I pressed the pound key, the call transfer command was run, and the revert was sent to the caller. The call was put on hold, and then a new call was started from my phone to my second hard phone, answered it, and then turned off the call. And everything it's just as simple as you can see. With only 2 lines, you could get this kind of behavior. Of course, you can have your own logic, like for for example, use pound 123 and transfer the call to 123 extension. You can do that as well. But yeah, that's as simple as it could have been. Let's see if there are any other questions. As my demos are done, my presentation is done. Let me know if I can answer any other questions now.
Yeah, I kind of commented it, but somebody asked if it works with Rtp Engine.
Yes. What works? So blocking the DTMFs work with Rtp Engine, and all the stuff that I've done works with Rtp Engine as well. So yeah. Okay. Follow up. Yeah, I guess there are no other. Somebody asked what kind of hard phones I'm using. I'm using a Yelink and a Snom. Probably this Snom is so that is no longer manufactured, but it works basically with any hard phone.
Really? Do we not have any other questions?
Okay, I either was so clear or nobody is
Actually,
interested in this.
Did we answer the question? I don't know if this is a question for you.
Okay.
I'm looking at the summit chat.
Okay.
So Arthur Soltanbekov, his first question was, is it true that every country has its own DTMF codes for in-band DTMF?
I don't think, I don't know, to be honest, but I don't think so.
No, I don't think this doesn't have to do with the countries. It's maybe the guy is mentioning what we all have seen, and Alex may have seen that also. Some providers are sending strange stuff inside your SBCs. That may be from most of the times from mobile carriers. So generally speaking, there shouldn't be any difference. Everyone should follow the protocols.
I agree.
So, there shouldn't be any difference at all. Maybe the guy who asked the question is mentioning what kind of problem. That's why he's asking. But generally, if he follows the non-compression advice, he should be fine.
He had a second part of a question too. He said, can RTProxy mute DTMF tones when it transcodes in-band DTMF to out-band DTMF?
Yeah, we've already answered that. No, it's not currently possible, but we're looking to.
Okay, we have another question that just came on. Any recommendations for DTMF security or privacy?
As Maxim said, from our side, we should be able to either mute or modify somehow or obfuscate the DTMF codes that are being sent further. So we shouldn't pass them along, at least not for this kind of sensitive information.
Yeah, there are some scenarios perhaps where you want to keep them, and some scenarios where you don't. So I guess
He's asking, like, what method would you guys recommend for DTMF delivery when entering credit card information?
In my, I mean, this is just a perspective. I would have wanted to hear something as if the other party would type something, but I shouldn't be able to understand what he was typing. So basically obfuscating in my opinion, but this is just my personal preference.
Sharad has another question. He says, if a call is established using Srtp, in RTP Engine, then OpenSIPS needs TLS certificate to receive the DTMF tones, correct or incorrect?
No, because well, when RTP Engine stands between Srtp and RTP, then he must decode that traffic. So he already knows everything. So you really don't need to. He already has all the keys to decrypt the traffics.
We have another question from Mark Farmer.
Hold on, Alex. But if it's just doing pass through, like you have Srtp flowing through the RTP engine, between the points. So without any kind of a conversion, in this case, I guess it will not have access.
Yeah, he would not have access to Srtp in this case, correct?
Okay.
So
it will not be able to extract the DTMFs.
Yeah.
Okay. Sorry, Alex. Go ahead.
Okay. Mark Farmer's question. Is there a plan to have RTP Engine notify multiple OpenSIPs?
Not that I'm aware of, but I'm not the guy you should be asking this question. I mean, it's a limit. It's a design limitation from RTP Engine, and hopefully they will soon sort it out or find a different solution.
Well, the question is, why would you need that to be done at the RTProxy level? Because we have something, better.
RTP Engine.
No,
It was on
well, no,
RTP Engine. Question.
Actually, it doesn't really matter. The whole idea, it's enough to have the DTMF indication delivered to only one OpenSIPS instance, and then you can easily use the clustering support between multiple OpenSIPS instances, and you have script functions to actually broadcast any kind of information from script level at the script level. So at the cluster level. So you can use the dedicated events in order to receive the DTMFs from RTProxy, Rtp Engine, and then through the clustering you can simply broadcast this information with all the OpenSIPS instances. So that will simply work.
There's another question, whether we can do directed call pickup via DTMF. Not sure what's the scenario. So
like a call ops question, but yeah, like for instance, in a lot of like PBXs, you've got a scenario, ringing a phone, and let's say somebody in the room wants to pick up that ringing phone. They're going to try to do a call pickup. And I think he's talking about trying to do this up at the OpenSIPS layer rather down at the PBX layer.
Actually, the question is what the DTMF have to do with this, because at least as far as I know, I don't pretend to be a PBX expert. When you do the call pickup, you either pick up any call, you just dial a star code just to pick up inside the group, or you may dial a star code, for the pickup service plus an extension if you want to do like a direct call pickup. But I'm not sure exactly where the DTMF will, fit in all this stuff.
Probably he is referring like inputting the pickup number after the call is being answered. I don't know.
He's right here. Unmute yourself, Vlad Payu.
No, not with his broken mic.
Vlad, hello.
Vlad, you can write it in the chat.
He did write it in the chat. That wasn't enough information for us to understand him.
Yeah, write more.
Well, no problem. We will answer him tomorrow during his presentation.
Yeah.
Nice.
Okay. We should probably wrap it up as.
If we can receive the DTMF event on the script level, we should be able to do it.
Probably yes.
Well,
Yeah,
the whole idea, it's the whole, with the call pickup. When you do the pickup, it's you're it's more like, let's say, the transactional level. You don't have a call answered, because when the pickup itself is completed as action, you're already connected with the, with the original caller. So, the whole pickup process is done. Makes no sense to do any DTMFs after that.
It kind of feels more like an unattended transfer, I think. Maybe you can trigger that via some DTMF, I believe. Anyway, we'll clear it out tomorrow. Yeah.
That was my last demo, how to do a call attended transfer using DTMF.
There you go.
Okay, thank you guys for paying attention. I'd be glad to discuss further in the chat room, but now Livio has to tell us how the quality-based routing works. So good luck, Livio.
Okay.
Thank you, Razvan. Let me
you.
turn on. Right. Congrats.
Can everyone still hear me?
Yep.
Yep, Alex is in there.
I lost my headset. Well,
Alex,
Razvan, thank you again. That was absolutely amazing. Lots of questions, lots of interest in what's going on over there. And we will have some follow-up to that and some presentations that'll be coming up.